Hey guys, my name is Mansoor. Welcome to my YouTube channel, The Coders Bridge. As you guys know, we are creating a deep learning playlist. So this is the third video of our playlist. If you haven't watched the previous videos, like what is deep learning and what are the IDs and libraries we will be using, please watch this video. Before coming to this, I will be giving the link in the I button, and I will be giving the link as well as in the description section. If you want to know more about deep learning or the end-to-end model, how deep learning works in the real with the real-time examples, please subscribe to my channel and stay with us. Okay, so now let's start our today's topic. What is activation functions and why it is used? Normally, in the name itself, you guys can identify activation function is nothing but it is activating something, correct? So we will see activation functions example in a real time with a human brain. Okay, so what is the use of activation function in a human brain? So here you can see, right, there is some human structure, like brain structure with some sense organs, as well as a human with a mosquito sitting in his hand. Just think, like, if a mosquito is biting us, suddenly some neurons are triggered in our brain, and it will send a signal to us like we need to do some action. Either we need to shake our hand, we need to hit the mosquito, some action we will be doing, right? Same when as soon as the mosquito hits, like bites us, touch we have many neurons, like a smell neuron, what is this, hearing, vision, taste, and touch. As soon as mosquito bites us, touch neuron gets activated or triggered. It sends a signal to us like we need to do perform something. Like if mosquito is biting, then only this touch neuron will be activated, and the value will be greater than 0 to greater than 0.5 to 1. Okay, if the mosquito is just sitting, it's not biting us, we will not feeling that, like mosquito is very less in weight, right? We'll be not feeling like some object is sitting in our hand. So then the the what is that, the sensitivity of this touch neuron will be 0 to 0.5, which is no neuron is get triggered. When the sensitivity is increased, that means from 0.5 to 1, then only the touch neuron get activated, and it triggered some message to our brain like we need to do, like perform some action to how to say, to come out of that mosquito bite or something, correct? Okay, we'll see like what how this what is that neuron performs in the deep learning mode. Okay, so here you can see, right, how like as I told in the first session itself, in all the like deep learning model, we will be having input and some weight will be assigned to each of the input, correct? As I told before, like they will be input is nothing but the object which we feed as an input to the deep learning model. So here we can see, right, there are three inputs, not three, like there are n number of inputs, a1 to an. Like we are assigning some weight to this to each inputs. Weight is nothing but we will be assigning some so we should like, if we doesn't add weight and bias, then our form like or our calculation will go in a linear way. Okay, so we will be adding some weight and bias, and at the end we will be having some activation functions. Okay, if we are not adding activation functions, then what will be the output? Output is nothing but the input value, which is a1, and the weight with bias, which is w1. We will be just finding the summation of all input and weight, which is um, how to say this, a1 into w1. Okay, we'll just take a scribbling pad. Okay, so what we will be doing, we will be just taking this a1. No, we will erase this. So actually first we will be taking a1, right? Okay, so we will be taking a1 w1 plus a2 w2 plus an wn. So we will be just finding the sum of all these values. We will be finding the sum of like a1 into like input plus weight, input into weight plus input into weight plus input into weight. That means we will be finding the summation of all the inputs with the y. Okay, and at the last some bias will be added. Okay, if we just look this calculation in the equation format, how does it looks like? Okay, let me just show you how it will be looking. Okay, So we'll consider our output as y, like y is equal to, when we are taking this calculation, which is a1 w1 plus a2 w2 plus now, as of now I am taking only two of these weights, and what is the bias, we will be adding bias. So if you just see, this is something looking like a linear equation, right? Y is equal to mx plus c. Okay, we'll, as of now, we'll take only one input plus weight. If you consider this thing, y is equal to mx plus b, which is, this is a linear equation. Okay, if we are not calculating our output with the activation function, then it will be a linear equation. um, if it is a linear equation, obviously the line will be passing through the slope, which is 0 to 0.5, then no neurons will be triggered. Okay, so that's why we are using activation functions to get to the, how to say it, like to get our output value or to get the neurons get triggered. Okay. Okay, now we'll move to our next slide. Okay, this is our next slide, which is types of activation functions. We have different types of activation functions like sigmoid, ReLU, leaky ReLU, eLoop, preloop, softmax, swish. So I have not added some other, like we have even some other activation functions like tanh, soft, what is that? Soft plus, swish ReLU. So we have n number of activation functions. So as of now, we'll see like what is the use of sigmoid, what is ReLU, what is the difference between ReLU and leaky ReLU. Say leaky ReLU is nothing but an updated version of ReLU to overcome some disadvantages. What is eLU? What is the difference between all the ReLU functions? What is softmax? When to use which functions? So we will be seeing in our next video. So this is just an introduction video of what is activation functions. So I hope like you guys now understand why we need activation function. Activation function is used to just trigger a neuron to get our desired output. Simple, in a simple way, like activation function is used to get a desired output by triggering a neuron. So when our when our output value triggers from 0.5 to 1, then only a neuron will be triggered in a I'm telling in a sigmoid like in a sigmoid explanation. So normally sigmoid explanation, we already saw the sigmoid explanation in a logistic regression. So we'll be seeing entire how to say, like entire explanation for each of this activation function. So for sigmoid there will be one video, for ReLU there will be another video, like all the activation functions will be an individual videos. So please stay with us, kindly subscribe to our channel, which is the Coders Bridge, and hit the like button if you like the video, comment if you need more videos on like activation functions, or if you have any doubts. Okay, thank you.